Desert. Chapter 5. Light, Air, and Color. These deserts, cut through from north to south by a silent river, and from east to west by two noisy railways, seem remarkable for only a few commonplace things, according to the consensus of public opinion. All that one hears or reads about them is that they are very hot, that the sunlight is very glaring, and that there is a sandstorm, a thirst, and death waiting for every traveler who ventures over the first divide. There is truth enough, to be sure, in the heat and glare part of it, and an exceptional truth in the other part of it. It is intensely hot on the desert at times, but the sun is not responsible for it precisely in the manner alleged. The heat that one feels is not direct sunlight so much as radiation from the receptive sands, and the glare is due not to preternatural brightness in the sunbeam, but to there being no reliefs for the eye in shadows, in dark colors, in heavy foliage. The vegetation of the desert is so slight that practically the whole surface of the sand acts as a reflector. And it is this, rather than the sun's intensity, that causes the great body of light. The white roads in southern France, for the surface they cover, are more glaring than any desert sands, and the sunlight upon snow in Minnesota or New England is more dazzling. In certain spots, where there are salt or soda beds, the combination of heat and light is bewildering enough for anyone, but such places are rare. White is something seldom seen on desert lands, and black is an unknown quantity in my observations. Even lava, which is popularly supposed to be as black as coal, has a reddish hue about it. Everything has some color, even the air. Indeed, we shall not comprehend the desert light without a momentary study of this desert air. The circumambient medium which we call the atmosphere is to the earth only as so much ground glass globe to a lamp, something that breaks, checks, and diffuses the light. We have never known, never shall know, direct sunlight, that is, sunlight in its purity undisturbed by atmospheric conditions. It is a blue shaft falling perfectly straight, not a diffused white or yellow light, and probably the life of the earth would not endure for an hour if submitted to its unchecked intensity. The white or yellow light known to us as sunlight is produced by the ground glass globe of air, and it follows readily enough that its intensity is absolutely dependent upon the density of the atmosphere, the thickness of the globe. The cause for thickening of the aerial envelope lies in the particles of dust, soot, smoke, salt, and vapor, which are found floating in larger or smaller proportions in all atmospheres. In rainy countries like England and Holland, the vapor particles alone are sufficiently numerous to cause at times great obscurity of light, as in the case of fog. And the air is only comparatively clear even when the skies are all blue. The light is almost always whitish, and the horizons often milky white. The air is thick, for you cannot see a mountain 15 miles away in any sharpness of detail. There is a mistiness about the rock masses and a vagueness about the outline. An opera glass does not help your vision. The obscurity is not in the eyes, but in the atmospheric veil through which you are striving to see. On the contrary, in the high plateau country of Wyoming, where the quantities of dust and vapor in the air are comparatively small, the distances that one can see are enormous. A mountain 70 miles away often appears sharp cut against the sky, and at sunset the lights and shadows upon its sides look only 10 miles distant. But desert air is not quite like the plateau air of Wyoming, though one can see through it for many leagues, It is not thickened by moisture particles, for its humidity is almost nothing, but the dust particles, carried upward by radiation and the winds, answer a similar purpose. They parry the sunshaft, break and color the light, increase the density of the envelope. Dust is always present in the desert air in some degree, and when it is at its maximum with the heat and winds of July, we see the air as a blue, yellow, or pink haze. This haze is not seen so well at noonday as at evening, when the sun rays are streaming through the canyons, or at dawn when it lies in the mountain shadows and reflects the blue sky. Nor does it muffle or obscure so much as the moisture-laden mists of Holland, but it thickens the air perceptibly and decreases in measure the intensity of the light. Yet despite the fact that desert air is dust-laden and must be thickened somewhat, there is something almost inexplicable about it. It seems so thin, so rarefied, and it is so scentless. I had almost said breathless, that it is like no air at all. You breathe it without feeling it. You look through it without being conscious of its presence. Yet here comes in the contradiction. Desert air is very easily recognized by the eyes alone. The traveler in California, when he wakes in the morning and glances out of the car window at the air in the mountain canyons, knows instantly on which side of the Tehachapi Range the train is moving. He knows he is crossing the Mojave. The lilac blue veiling that hangs about those mountains is as recognizable as the sea air of the Massachusetts shore. And strange enough, the sea breezes that blow across the deserts all down the Pacific coast have no appreciable effect upon this air. The peninsula of Lower California is practically surrounded by water, but through its entire length and down the shores of Sonora to Mazatlan, there is nothing but that clear, dry air. I use this word clear because one can see so far through this atmosphere, and yet it is not clear, or we should not see it so plainly. There is the contradiction again. It is perhaps the coloring of it that makes it so apparent. Probably. Even the clearest atmosphere has some coloring about it. Usually it is an indefinable blue. Air blue means the most delicate of all colors, something not of surface depth but of transparency, builded up by superimposed strata of air many miles perhaps in thickness. The air blue is seen at its best in the gorges of the Alps and in the mountain distances of Scotland, but it is not so apparent on the desert. The coloring of the atmosphere on the Colorado and the Mojave is oftener pink, yellow, lilac, rose color, sometimes fire red. And to understand that we must take up the ground glass globe again. It has been said that our atmosphere breaks, checks, and diffuses the falling sunlight like the globe of a lamp. It does something more. It acts as a prism and breaks the beam of sunlight into the colors of the spectrum. Some of these colors it deals with more harshly than others because of their shortness and their weakness. The blue rays, for instance, are the greatest in number, but they are the shortest in length, the weakest in traveling power of any of them. Because of their weakness and because of their affinity as regards to size, with the small dust particles of the higher air region, great quantities of these rays are caught, refracted, and practically held in check in the upper strata of the atmosphere. We see them massed together overhead and call them the blue sky. After many millions of these blue rays have been eliminated from the sunlight, the remaining rays come down to Earth as a white or yellow, or at times reddish light, dependent upon the density of the lower atmosphere. Now it seems that an atmosphere laden with moisture particles obstructs the passage earthward of the blue rays, less perhaps than an atmosphere laden with dust. In consequence, when they are thus allowed to come down into the lower atmosphere in company with the other rays, their vast numbers serve to dominate the others and to produce a cool tone of color over all. So it is that in moist countries like Scotland, you will find the sky cold blue and the air tinged gray, pale blue, or at twilight in the mountain valleys. A chilly purple, a dust-laden atmosphere seems to act just the reverse of this. It obstructs all the rays in proportions to its density, but it stops the blue rays first, holds them in the upper air, while the stronger rays of red and yellow are only checked in the lower and thicker air strata near Earth. The result of this is to produce a warm tone of color overall. So it is that in dry countries like Spain and Morocco, or on the deserts of Africa and America, you will find the sky rose-hued or yellow and the air lilac, pink, red, or yellow. I mean, now that the air itself is colored, of course countless quantities of light beams and dispersed rays break through the aerial envelope and reach the earth. Else, we should not see color in the trees or grasses or flowers about us. But I am not now speaking of the color of objects on earth, but of the color of air. A thing too intangible for color, you think? But what of the sky overhead? It is only tinted atmosphere. And what of the bright-hued horizon skies at sunrise and sunset, the rosy yellow skies of Indian summer? They are only tinted atmosphere again. Banked up in great masses and seen at long distances, the air color becomes palpably apparent. Why then should it not be present in shorter distances, in mountain canyons, across mesas and lomas, and over the stretches of the desert plains? The truth is, all air is colored, and that of the desert is deeper dyed and warmer hued than any other for the reasons just given. They are only tinted atmospheres again. Banked up in great masses and seen at long distances, the air color becomes palpably apparent. Why, then, should it not be present in shorter distances, in mountain canyons, across mesas and lomas, and over the stretches of the desert plains? The truth is, all air is colored, and that of the desert is deeper dyed and warmer hued than any other for the reasons just given. It takes on many tints at different times, dependent upon the thickening of the envelope by host and dust-diffusing winds. I do not know if it is possible for fine dust to radiate with heat alone, but certain it is that, without the aid of the wind, there is more dust in the air on hot days than at any other time. When the thermometer rises above 100 degrees Fahrenheit, the atmosphere is heavy with it, and the lower strata are dancing and trembling with phantoms of the mirage at every point of the compass. It would seem as though the rising heat took up with its countless small dust particles, and that these were responsible for the rosy or golden quality of the air coloring. There is a more positive tinting of the air produced sometimes by high winds. The lighter particles of sand are always being drifted here and there through the aerial regions, and even on still days, the whirlwinds are eddying and circling, lifting long columns of dust skyward, and then allowing the dust to settle back to earth through the atmosphere. The stronger the wind and the more of dust and sand, the brighter the coloring. The climax is reached in dramatic sandstorm, a veritable sand fog which often turns half the heavens into a luminous red and makes the sun look like a round ball of fire. The dust particles in itself is sufficient to account for the warmth of coloring in the desert air, sufficient in itself to produce the pink, yellow, and lilac hazes. And yet I am tempted to suggest some other causes. It is not easy to prove that a reflection may be thrown upward upon the air by the yellow face of the desert beneath it, a reflection similar to that produced by a fire upon a night sky. Yet I believe there is something of the desert air coloring derived from that source. Nor is it easy to prove that a reflection is cast by blue, pink, and yellow skies upon the lower air strata. Yet certain effects shown in the mirage, the water illusion, for instance, which seem only the reflection of the sky from heated air, seem to suggest it. And if we put together other casual observations, they will make argument toward the same goal. For instance, the common blue haze that we may see any day in the mountains is always deepest in the early morning when the blue sky over it is deepest. At noon, when the sky turns gray-blue, the haze turns gray-blue also. The yellow haze of the desert is seen at its best when there is a yellow sunset, and the pink haze when there is a red sunset, indicating that at least the sky has some part in coloring by reflection the lower layers of the desert air. Whatever the cause, there can be no doubt about the effect. The desert air is practically colored air. Several times from high mountains I have seen it lying below me like an enormous tinted cloud or veil. A similar veiling of pink lilac or pale yellow is to be seen in the gorges of the Grand Canyon. It stretches across the Providence Mountains at noonday and is to be seen about the peaks and packed in the valleys at sunset. It is dense down in the Coahuila Basin. It is denser from range to range across the hollow of Death Valley, and it tinges the whole face of the Painted Desert in Arizona. In its milder manifestations, it is always present, and during the summer months its appearance is often startling. By that I do not mean that one looks through it as through a highly colored glass. The impression should not be gained that this air is so rose-colored or saffron-hued that one has to rub his eyes and wonder if he is awake. The average unobservant traveler looks through it and thinks it's not different from any other air. But it is different. In itself and in its effect upon the landscape, it is perhaps responsible for the greater part of what everyone calls the wonderful color of the desert. And this not to be the obliteration of local hue in sands, rocks, and plants. Quite independent of atmospheres, the porphyry mountains are dull red. The greasewood is dull green. The vast stretches of sand are dull yellow. And these large bodies of local color have their influence in the total sum up. Slight as is the vegetation upon the desert, it is surprising how it seems to bunch together and count as color mass. Almost all the growths are over-green. The shrubs and the trees shed their leaves, to be sure, but they do it so slowly that the new ones are on before the old ones are off. The general appearance is always green, but not a bright hue, except after prolonged rains. Usually, it is an olive bordering upon yellow. One can hardly estimate what a relieving note this thin thatch of color is, or how monotonous the desert might be without it. It is welcome, for it belongs to the scene and fits in the color scheme of the landscape as perfectly as the dark green pines in the mountain scenery of Norway. The sands, again, form vast fields of local color, and indeed the beds of sand and gravel, the dunes, the ridges, and the mesas make up the most widespread local hue on the desert. The sands are not golden except under peculiar circumstances, such as when they are whirled high in the air by the winds, and then struck broadside by the sunlight. Lying quietly upon the earth, they are usually a dull yellow. In the morning light, they are often gray, at noon frequently a bleached yellow, and at sunset occasionally pink or saffron-hued. Wavering heat and mirage give them temporary coloring at times that is beautifully unreal. They then appear to undulate, slightly like the smooth surface of a summer sea at sunset, and the colors shift and travel with the undulations. The appearance is not common, perfect calm, a flat plain, and intense heat being apparently the conditions necessary to its existence. The rocks of the upper peaks and those that make the upright walls of mountains, though small in body, lying quietly upon the earth, they are usually a dull yellow, and in the morning light they are often gray, at noon frequently a bleached yellow, and at sunset occasionally pink or saffron-hued. The sands are not golden, except under peculiar circumstances, such as when they are whirled high in the air by the winds, and then struck broadside by the sunlight. Lying quietly upon the earth, they are usually a dull yellow in the morning light. They are often gray. At noon they are frequently a bleached yellow, and at sunset occasionally pink or saffron-hued. Wavering heat and mirage give them temporary coloring at times that is beautifully unreal. They then appear to undulate slightly like the smooth surface of a summer sea at sunset, and the colors shift and travel with the undulations. The appearance is not common, perfect calm, a flat plain, and intense heat being apparently the conditions necessary to its existence. The rocks of the upper peaks and those that make the upright walls of mountains, though small in body of color, are perhaps more varied in hue than either the sands or the vegetation, and that, too, without primary notes as in the Grand Canyon of the Yellowstone. The reds are always salmon-colored, terracotta, or Indian red. The greens are olive-hued, plum-colored, sage green. The yellows are as pallid as the leaves of yellow roses. Fresh breaks in the wall of rock show brighter colors that have not yet been weather-worn, or they may reveal the oxidation of various minerals. Often long strata and beds and even whole mountains tops show blue and green with copper, or orange with iron, or purple with slates, or white with quartz. But the tones soon become subdued. A mountain wall may be dark red within, but it is weather-stained and lichen-covered without. Long-reaching shafts of granite that loom upward from a peak may be yellow at the heart, but they are silver-gray on the surface. The colors have undergone years of toning down, until they blend and run together like the faded tints of an eastern rug. But granted, the quantity and the quality of local colors in the desert, and the fact still remains that the air is the medium that influences if it does not radically change them all. The local hue of a sierra may be gray, dark red, iron-hued, or lead-colored, but at a distance, seen through dust-laden air, it may appear topaz yellow, sapphire blue, bright lilac, rose red, yes, fire red. During the heated months of the summer, such colors are not exceptional. They appear almost every evening. I have seen at sunset, looking north from Sonora some 20 miles, the whole tower-like shaft of Babacovari change from blue to topaz and from topaz to glowing red in the course of half an hour. I do not mean edgings or rims or spots of these colors upon the peak, but the whole upper half of the mountain completely changed by them. The red color gave the peak the appearance of hot iron, and when it finally died out, the dark, dull hue that came after was like that of a clouded garnet. The high ranges along the western side of the Arizona and the buttes and tall spires in the upper basin region all show these warm fire colors under heat and sunset light, and often in the full of noon. The colored air in conjunction with light is always responsible for the hues. Even when you are close up to the mountains, you can see the effects of the air in small ways. There are edgings of bright color to the hill ridges and the peaks, and in the canyons where perhaps a sun shaft streams across the shadow. You can see the gold or fire color of the air most distinctly. Very beautiful are these golden sun shafts shot through the canyons, and the red shafts are often startling. It would seem as though the canyons were packed thick with yellow or red haze, and so in reality they are. There is one marked departure from the uniform warm colors of the desert that should be mentioned just here. It is the clear blue seen in the shadows of western-lying mountains at sunset. This colored shadow shows only when there is a yellow or orange-hued sunset, and it is produced by the yellow of the sky casting its complementary hue or blue in the shadow. At sea, a ship crossing a yellow sunset will show a marvelous blue in her sails, just as she crosses the line of the sun, and the desert mountains repeat the same complementary color with equal facility and great variety. It is not of long duration. It changes as the sky changes, but maintains always the complementary hue. The presence of the complementary color in the shadow is exceptional, however. The shadows cast by such objects as the saguaro and the palo verde are apparently quite colorless, and so too are the shadows of passing clouds. The colored shadow is produced by reflection from the sky, mixed with something of local color in the background, and also complementary colors. It is usually blue or lilac blue or snow, for example, when there is a blue sky overhead, and lilac when shown upon sand or a bluestone road. Perhaps it does not appear often on the Mojave Colorado because the surfaces are too rough and broken with coarse gravel to make good reflectors of the sky. The fault is not in the light or in the sky, for upon the fine sands of the dunes and upon beds of fine gypsum and salt, you can see your own shadow of colors and absolute indigos, and often upon boulders of white quartz, the shadows of cholla and the greasewood are cast in almost cobalt hues, that is, cobalt hues. All color, local, reflected, translucent, complementary, is, of course, made possible by light and has no existence apart from it. Through the long desert day, the sunbeams are weaving skins of color across the sands, along the sides of the canyons and about the tops of the mountains. They stain the ledges of copper with turquoise. They burn the buttes to a terracotta red. They paint the sands with rose and violet, and they key the air to the hue of the opal. The reek of color that splashes the western sky at sunset is but the climax of the sun's endeavor. If there are clouds stretched across the west, the ending is usually one of exceptional brilliancy. The reds are all scarlet, the yellows are like burnished brass, the oranges like shining gold. But the sky and clouds of the desert are of such unique splendor that they call for a chapter of their own.